Imagine this. Every time you glance at a clock, you're not just checking the time. You're reading hidden instructions left by some ancient engineers, a civilization that disappeared before anyone started writing history down. The circle at the bottom of your compass, the way you count hours, even the degrees you use to find your way, maybe none of it started with us. Maybe we just inherited these systems from people who vanished under floodwaters 5,000 years ago. Walk into a quiet museum archive. There, behind glass clay tablets sit in silence, still humming with purpose. The Sumerians pressed those marks into wet mud thousands of years ago, each tiny wedge a clue. Measurements, ratios, astronomical alignments, all so precise they still shape your life, even if you've never really noticed. The Sumerians called the original designers the Anunnaki. And if you really listen to those tablets, if you let them whisper across the ages, you start to get this uneasy feeling. We never stopped following the old instructions. We just forgot who gave them to us. Before we get into the math that quietly runs your world, take a second. If you're into history that makes you rethink everything, subscribe. And if you're still here, listening in the dark, drop a comment. Where are you and what time is it? I like to picture all of us, scattered across time zones, sitting together in this hush, tracing fingerprints left by people who measured time before any of us thought to claim we invented it. This discovery didn't come with fireworks. It came with dust and silence, the way truth usually does when it's spent 5,000 years underground. In winter, 1849, a British diplomat named Austen Henry Layard was digging outside ancient Nineveh. His workers stumbled on something that cracked open what we thought we knew about the past. Buried in ruined libraries and palace rubble, they found thousands of clay tablets covered in wedge-shaped script. When linguists finally cracked the code years later, they weren't looking at crude myths or some beginner's scribbles. They were reading mathematics. Not just basic math either. Advanced stuff, astronomical tables, geometric formulas, blueprints, all written in a number system so smooth and clever that we still use it today without ever asking where it came from. The Sumerians, writing in mud around 3200 BCE, used base 60 math. Sexagesimal, not base 10, the one that feels natural because we've got 10 fingers. Not base 12, which pops up in dozens and lunar hours. Base 60, a number with more divisors than anything smaller, perfect for trade, astronomy, construction, timekeeping. 60 minutes in an hour, 60 seconds in a minute, 360 degrees in a circle. None of this is random or just cultural drift. It's an inheritance. And here's the strange thing, the Sumerians never said they invented it. Over and over in text after text, temple inscription after temple inscription, they use the same words almost like a mantra, from distant days, from ancient times, according to the old writings. They sound more like archivists than inventors, caretakers of a system that was already old when they found it. But the story just gets weirder. These tablets don't just hold onto the math, they give names. The Anunnaki, not far-off, unknowable gods, but administrators, teachers, people who supposedly walked among humans and laid down the blueprints for civilization. Enki, who handled sacred knowledge and fresh water, is the one who revealed the ME, the divine principles behind civilization, including math, astronomy, engineering. Enlil, who managed atmosphere and agriculture, set up the calendar. Ningirsu marked out the measuring rod and survey lines. Inanna ran the show for Venus and tracked her celestial cycles. These aren't gods waving their hands to make worlds out of nothing. They're system builders, organizers, teachers, and the instructions they left, written in base 60 math and mapped out in the stars, still run everything from your clocks to your calendars, to the ways you cut a circle into pieces. We're living in a world they measured, even if we forgot their names. Most people never stop to wonder why a circle has 360 degrees. It just feels right, one of those things that seems set in stone. But the truth is, math systems aren't handed down by the universe. People choose them. Base 60 isn't obvious, and it sure doesn't come from counting on your fingers. Someone had to notice that 60 divides neatly by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. That's not finger counting. That's deep math, someone searching for the most flexible number they could find. The Sumerians had this figured out from the very beginning. There's no sign they stumbled into it, no period of trial and error in the archaeological record. When Samuel Noah Kramer, an American archaeologist, spent decades at Penn translating Sumerian tablets back in the mid-1900s, he came up with a phrase that still sticks with historians. History begins at Sumer. Not because humans didn't exist before, but because Sumer shows up already organized, already sophisticated, already running on mathematical rules that Europe wouldn't rediscover until the Renaissance. Kramer found multiplication tables that ran into the thousands, division problems with complicated fractions, geometric calculations for odd-shaped fields, even compound interest formulas. And every time, the Sumerians credited these breakthroughs not to clever humans, but to the gods. They used the word me. People usually translate it as divine decree or sacred principle, but honestly it's closer to fundamental code. The ME aren't commandments or moral laws. They're instructions, blueprints for civilization. The texts list over 100 ME, covering everything from kingship and ritual to metalwork, music, and sex. But the ones that come up the most: measurement, calculation, and watching the skis. To the Sumerians, math wasn't something people invented. It was a gift, handed down from the Anunnaki, the gods who knew it all before humans even existed. Picture this. In a quiet, dim corner of the British Museum, if you could get past the security, you might hold tablet K160, a piece dug up from the library at Nineveh. The clay feels cool and rough, the edges worn down by time. Pressed into its surface are wedge-shaped marks, a geometric puzzle involving right triangles. The solution, what we now call the Pythagorean theorem, a 2 plus b2 c2, used to find the diagonal of a rectangle. The tablet dates to around 1800 BCE. Pythagoras wouldn't show up for another 12 centuries. But here's the formula, treated like old news, copied from even older sources the scribe calls ancient writings from before the Great Change. What was that great change? The scribe doesn't say, but Sumerian history splits everything into before and after the flood. In the stories about the world before the flood, math isn't something people struggled to invent. The Anunnaki already had it. They taught it to people as part of the starter kit for building a real society. The instructions were there first. People caught up later. Fast forward to the 1950s. Otto Neugebauer, a mathematician and historian at Brown, spent years poring over Babylonian astronomical tablets, the next chapter after Sumerian math. He found records that predicted lunar eclipses with eerie accuracy, lining up with modern computer calculations. He found tables tracking Venus's 584-day cycle, accurate to within a single day, decade after decade. That's not just keeping an eye on the sky. That's using math to break down cycles, spot ratios, and predict what's coming. When Neugebauer published his book, The Exact Sciences in Antiquity, he kept circling back to the same unsettling point. The Babylonians, and the Sumerians before them, had a level of mathematical astronomy that shouldn't show up for another 2,000 years. They modeled planets with geometry, predicted the heavens with algorithms, and ran their calculations in base 60. When modern astronomers first read these tablets, they had to double-check with computers just to believe the ancients actually pulled it off. But here's the thing Neugebauer couldn't wrap his head around. No one really has, honestly. Where did the Sumerians get this whole base 60 idea in the first place? Math systems don't just appear out of nowhere. Usually they grow out of daily life. Egyptians went with base 10 because, well, you've got 10 fingers. Mayans counted everything, fingers and toes, so base 20 just made sense. The Babylonians, they picked up base 60 from the Sumerians. But the Sumerians themselves, it's like the system just dropped out of the sky. There's nothing before it, no older culture in Mesopotamia dabbling with proto-base 60, No slow build in the archaeology. It shows up fully formed, right there in the oldest math tablets, as if it had always been there. Unless it actually was. Maybe the Sumerians didn't invent base 60 at all. Maybe they got it from somewhere or someone else. The Anunnaki, according to the old texts, handed down math before humans even cared about it. They set up the measuring rods, the units, the whole structure we ended up treating almost like a sacred inheritance, too perfect to mess with, too important to lose. Imagine sitting in a Sumerian scribal school in Adaba about 2500 BCE. You're just a kid, maybe 12, scratching out multiplication tables on a lump of clay. Your teacher hovers behind you, nudges your hand, gets you to hold the stylus right. The table you're copying, multiples of 60. 60 times 1, 60. 60 times 2, 120, and on it goes. You don't ask why 60 matters. You don't wonder who decided a circle should have 360 degrees, or why each degree gets chopped into 60 minutes. That's just how things are. These rules were here before you, before your teacher, before anyone you know. And if you ever did ask, everyone gives the same answer. From ancient times, according to the old writings, the Anunnaki set the rules. Nobody claims they figured it out themselves or that their ancestors stumbled onto it. This knowledge came from outside, from those who ruled before the flood. They put the instructions in clay and left, and humans copied them, generation after generation, scared to change a thing. Because it all worked so well, changing it seemed like asking for disaster. Those tablets aren't just math for math's sake. They're instruction manuals for life, even now. When you board a plane and the pilot says they're heading 270 degrees west, or when they talk about cruising at 35,000 feet, you're hearing Sumerian math echo across 5,000 years. Navigation. It's all about circles, 360 degrees, split into base 60 minutes and seconds, because that's how the Anunnaki taught the Sumerians to measure space. GPS satellites. They run on formulas straight out of Mesopotamian star charts. The tech is new, but the framework, ancient. Here's a detail that should give you pause next time you check your watch. Dividing the day into 24 hours, each hour into 60 minutes, each minute into 60 seconds, it's not just natural. The Earth doesn't demand it. Egyptians split day and night into 12 hours each, but their hours stretched and shrank with the seasons. Sumerians, they came up with fixed hours. Why 24? Because it divides so neatly with the numbers that mattered to them. 12, 6, 4, 3, 2. Everything lined up. Every calculation clicked. You wake up to an alarm at 6:30, a base 60 slice of a 24-hour day. 3 minutes for coffee, another base 60 chunk. Drive to work, and your GPS uses degrees, minutes, and seconds to pin your spot on the globe. You sit through a 90-minute meeting, check the forecast for 72 degrees, spin a compass divided into 360 degrees. Every single thing follows instructions the Anunnaki handed down to the Sumerians 5,000 years back. You've never met them. Maybe you don't buy the story at all, but you live by their system every hour, every day. Sitting in the archives at Penn's Museum of Archaeology and Anthropology, there's a clay tablet, CBS 8536. It's old, about 2100 BCE. A student at Nippur, Sumer's scribal heart, scratched out a math problem: how to measure an uneven plot of land, the kind of thing you'd need for taxes or selling a field. The tablet shows each step: measure the sides, adjust for the weird shape, plug it into the formula, get an answer in cubic units, all in that Sumerian base 60. The amazing part isn't that this student did the calculation. What really stands out is the formula itself. Here we have a piece of elementary school homework, written 4,000 years ago, and the math is spot on, mathematically optimal. If you handed the same irregular polygon to a surveyor today, they'd use the same method, just swapping decimals for the Sumerians' base 60 numbers. It's not some rough guesswork. The Sumerian approach nails it. And the oldest texts don't even bother to explain how they got there. The formula just shows up as if it's always been there, handed down, not figured out. You see this everywhere you look in Sumerian technical writing. Their medical texts set out dosages, 1/60th of a unit for this, 3/60ths for that, using their base 60 system. Modern pharmacology has double-checked those recipes, and sure enough, those ratios deliver real, biologically active results. Their architects worked with geometric ratios, calculating the proportions of temples and ziggurats with the same base 60 math. These weren't just big piles of mud bricks. The structures line up with the stars, the sight lines work, the acoustics are intentional. Sumerian music theory, same story. They broke up the octave using small whole number ratios, just like Western music does now, and their base 60 math kept the calculations neat and tidy. But nothing really compares to the way they handled astronomy. Some of the Sumerian tablets record observations and predictions that, honestly, shouldn't have been possible unless you had centuries, maybe even longer, of accumulated knowledge. Take the Venus tablet of Mesopotamian. It was copied around 1650 BCE, but the data goes way back. The thing tracks Venus's appearances and disappearances over 21 years. It marks when Venus rises before the sun, when it sets after, how long it's visible, and how long it vanishes behind the sun's glare. Venus isn't simple to follow. Its synodic period, basically the time it takes to get back to the same spot relative to Earth and the sun, is about 584 days. But with our year at roughly 365 days, the pattern never lines up perfectly. It keeps shifting. To spot the full cycle, you'd have to watch Venus for decades, compare notes, and figure out when things repeat. That's what's in the Mesopotamian tablet. It doesn't just collect raw numbers, it predicts future patterns based on real cycles. This is full-on mathematical astronomy, not just stargazing for fun. And the Sumerians didn't pretend this knowledge came from nowhere. The texts credit Anu and Enlil, the chief Anunnaki, right alongside the math. Anu, whose name literally means heaven, represents the sky, the fixed stars, the great cosmic dome. Enlil is the one for wind, weather, and the changing seasons. Together, they tie the sky and earth together, syncing celestial rhythms with farming, sailing, rituals, everything that kept life running smoothly. The relationship wasn't worship in the way later cultures worship distant gods. The Sumerians treated Anu and Enlil almost like consultants. Temple hymns describe priests making offerings and asking for help with their observations, not as if the gods were unreachable, but as if they were experts you could approach for advice. And a lot of the time, consulting meant diving into old tablets, reading ancient records, copying math from sources so old nobody remembered where they came from. This wasn't mystic revelation, it was archive work. The knowledge was kept in temple libraries, guarded by scribes who treated the texts as technical manuals, practical instructions for running a civilization they inherited, not invented. There's a hymn to Nisaba, goddess of scribes and grain, that opens with a simple request. Let her open the house of learning and reveal the ME. The language is revealing. The ME aren't things you create by studying. You don't build them from scratch. You unlock them, almost like opening a door to something that's already there, waiting for you. In Sumerian thought, learning isn't about inventing new knowledge. It's about recovering what already exists, getting yourself in sync with wisdom passed down by those who came before you. And if you follow those ancient instructions to the letter, they actually work. Modern science backs them up. Sumerian astronomical tables can predict eclipses. Their medical recipes still deliver real therapeutic effects. Their buildings, designed with ancient proportions, turn out stable and have great acoustics. Their math formulas can solve tough problems fast. The thing is, the system works. That's hard to brush off. If the Anunnaki were nothing but myth, just symbols for human ambition, why do their instructions hold up so well? Why does base 60 math still run our clocks, our navigation, our geometry, if it was just a random choice? Picture a quiet corner in the Louvre. There's a Sumerian clay cone there, small enough to fit in your hand. It's from around 2400 BCE, found in Girsu, buried in a temple's foundation. Its surface is covered in cuneiform, recording the construction of a sanctuary to Ningirsu, the city god. Most koans like this repeat the usual stuff: praise for the king, blessings from the gods, but this one sneaks in something odd. After describing the temple's construction, the text says the dimensions were measured with the old cubit, the sacred unit set by the Anunnaki ages ago and not to be changed. The scribe lists the measurements in cubits, a Sumerian unit about half a meter long. But here's the catch. The cubit isn't just a tool people picked because it was handy. It's sacred, fixed by the gods, and off limits for change. So measurement itself isn't a human invention. It's inherited, almost a command. You see this attitude everywhere in Mesopotamian life. Weights and measures weren't just government policy. They reached back to ancient authority. The mina, the shekel, the cubit, all supposedly matched proportions handed down by the Anunnaki. Cheating the scales wasn't just bad business. It was a kind of cosmic crime, a way of corrupting the ME. Legal texts talk about punishing merchants who use false measures, not mainly because customers get hurt, but because it upsets the cosmic balance. The measuring system is sacred because it ties everyday trade to the math of the heavens. To lie with weights is to lie about reality. There's a story about an American archaeologist, Herman Hilprecht, who dug at Nippur in the early 1900s. He found thousands of clay tablets in the temple library, many filled with mathematical tables. He spent years sorting through them, and one thing kept bothering him. The math tablets didn't seem to evolve. The oldest ones, from about 2500 BCE, were just as advanced as ones 1,000 years younger. There were no rough drafts, no messy beginnings, nothing that looked like people feeling their way. Sumerian math seemed to show up already fully formed, like it had been imported or inherited from someplace or someone, now lost to history. Hilprecht wasn't the kind of scholar who chased headlines. He liked to play it safe, to stick to the facts. But in a letter to a colleague, one that's still tucked away in the university archives, he confessed something strange. When he studied those ancient tablets, they didn't feel like the work of individual people. They felt like copies, as if every scribe was working from the same master text. The formulas and numbers stayed exactly the same, no matter the city, the century, or the school. It was so consistent, any change seemed out of the question. And when Hilprecht compared the oldest Sumerian tablets to even older Akkadian translations, he noticed a pattern. Akkadian scribes sometimes added a note, something like, "We copied this from the Sumerian according to the ancient writings. Don't change it." This obsession with getting the math exactly right lasted thousands of years. Take Nebuchadnezzar II, the famous Babylonian king. When he restored the Enki ziggurat around 600 BCE, he left a foundation inscription saying he rebuilt it using the ancient measurements. Same old cubit, same proportions as the original, nothing new. That's wild, because Nebuchadnezzar ruled almost 2,000 years after the first Sumerian ziggurats, but he insisted he wasn't inventing anything. He was restoring something that came from a time even older than his own. The way they measured the ziggurat is pure base 60 math. The Enki supposedly had a base that was a perfect square, 300 cubits on each side, which divides evenly by 60. The height, also 300 cubits, so the whole thing had a 1-to-1 ratio, height to width. Each of the 7 levels shrank in perfect proportion. The math calculated so the ratios lined up like notes in a musical scale. They weren't just stacking bricks. They were making math you could walk on, a giant physical demonstration of the sexagesimal system. It wasn't just a building, it was a statement. This is how the universe works, just like the Anunnaki supposedly taught us. But why 60? That question keeps mathematicians up at night. If you're inventing a number system from scratch, why not 10 or 12? What's so special about 60? Here's the answer: divisibility. 60 is the smallest number you can divide by 1, 2, 3, 4, 5, and 6 and always get a whole number. That's a big deal, especially for trade, splitting up grain, dividing goods, making deals. In base 60, you can cut up a bushel into halves, thirds, quarters, fifths, sixths. No messy fractions, just whole numbers. No other small number lets you do all that. But to figure that out, you need some serious mathematical thinking. You don't just stumble into base 60 by accident. You have to work it out, test the numbers, decide which one is best for dividing things up, then build your whole system around it. And then train everyone, scribes, merchants, officials, to use it. That's not something that just happens over time. Someone had to create it, set the rules, and make sure everyone from Ur to Nippur to Eridu played by them. Every tablet, every symbol, every calculation, same system everywhere. So who gets the credit? The Sumerians pointed to the Anunnaki, specifically Enki, their god of wisdom and water. They said Enki gave humanity the Me, the divine rules of measurement and calculation. His temple at Eridu, the Abzu, was supposed to be a vault for sacred knowledge. Stories say Enki kept tablets with all the Me, guarding them closely. He only let humans have them when the gods agreed people were ready. There's even a myth where Inanna tricks Enki into giving her some of the Me, including the secrets of writing and math, and then brings them to Uruk, turning her city into a learning powerhouse. A lot of people read that story as a metaphor for cities sharing knowledge, but look closer at how it's told. In these myths, knowledge isn't something people gradually figure out. It comes from someone who already owns it, Enki, and gets handed down, fully formed. Inanna receives it, then passes it on to people. The knowledge exists before anyone uses it. It's finished before humans even see it. And once you have it, you don't mess with it. You copy it exactly, keep it safe, and pass it down, because losing it means losing the link to where it all began. This is why so many Sumerian math tablets show up as copies. The scribes weren't coming up with new ideas. They were just rewriting stuff from older texts. And those originals, they were already considered ancient when the first Sumerian scribes got their hands on them. If you try to chase the trail back, it disappears into a past the Sumerians themselves couldn't reach. A time before their civilization, before their cities, before the flood that split history in two. At the very start of that chain, the texts always point to the Anunnaki, the ones who, according to tradition, passed down all knowledge. Now tucked away in the Oriental Institute at the University of Chicago, there's this clay prism, about the size of a wine bottle. They call it the Weld-Blundell prism. It's one of the best preserved copies of the Sumerian king list, dated around 2100 BCE. Each of its 4 sides carries 18 columns of cuneiform, listing every Sumerian ruler from the dawn of time up to the scribes present. But the beginning of time here doesn't mean the first humans. It starts when, according to the document, kingship was lowered from heaven. The opening line, after the kingship descended from heaven, the kingship was in Eridu. Then comes a roll call of pre-flood kings, each supposedly ruling for tens of thousands of years. Alulim, 28,800 years. Alaulgar, 36,000 years. Enmenluana, 43,200 years. The numbers aren't random. They're all multiples of 3,600, which the Sumerians called a sar. That's their way of counting huge stretches of time. So the list isn't really about the lives of kings. It's math in disguise. These reigns encode astronomical cycles, written out as kingly lifespans, all calculated with base 60 math so the chronology could survive across centuries. Here, where it gets interesting for our math story. The SAR, 600 years, is a sexagesimal number. 60 times 60 is 3,600. The Sumerians used it for astronomy because some celestial cycles line up as multiples of a SAR. For example, the precession of the equinoxes, the slow wobble of Earth's axis that takes about 26,000 years, breaks down to about 7 SARs. Jupiter and Saturn's orbits create repeating patterns measured in SARs, too. So those pre-flood kings, they weren't real people. They were markers for epochs, each one representing a SAR cycle where the Anunnaki watched the skies and recorded the math in base 60. Then came the flood. The king list barely pauses. The waters came, the world ended. Afterward, kingship descended from heaven again, but this time it landed in Kish. The pattern changed. The kings ruled for centuries instead of thousands of years, then decades, and finally lifespans that make sense for actual humans. Something fundamental shifted. The astronomical ages ended. Human history started. But the math stuck around. The base 60 system survived, thanks to the people who picked up the pieces. Scribes kept copying the old formulas, even when nobody remembered why, passing them through the ages so that post-flood civilization could still use the ancient instructions. And those instructions, they're not relics, they still shape your world right now. When the Hubble Space Telescope measures the angle between galaxies, it uses degrees, arc minutes, and arcsecond, sexagesimal slices of the sky. GPS satellites, their orbits rely on trigonometry built on 360-degree circles. Even physicists chasing nanoseconds are counting in seconds, which break down into minutes and hours, all base 60. The Anunnaki system didn't disappear. It became so deeply woven into everything we do, we don't even notice it's a choice. It's just how we measure time and space. Meanwhile, in a climate-controlled room at Yale, there's this little clay tablet, YBC 7289, sitting quietly in storage. It fits in your hand. On its face, someone drew a square with its diagonals. Along one diagonal, a cuneiform number, 1245110 in sexagesimal. That's 1.414213 in decimal, almost exactly the square root of 2, accurate to within a millionth of today's calculation. Someone figured that out around 1800 BCE. Not bad. How does a Sumerian student, scribbling out a homework problem thousands of years ago, land on a calculation so precise it matches what a modern computer would spit out? Simple. The method for finding square roots wasn't invented in their classroom. It was something they inherited. You see it on old mathematical tablets, just the instructions, no backstory, no hint at how anyone came up with it. Follow these steps, repeat until the answer settles down. That's it. And it works. When mathematicians first looked at the YBC 7289 tablet, they checked the numbers and realized the Sumerians were running the same kind of iterative algorithm computers use today. The only difference, they did it by hand, pressing numbers into clay. But these kinds of algorithms don't just appear out of nowhere. Someone has to notice that if you keep refining your answer, you get closer to the truth. That's a big leap. It means seeing math as a process, a sequence of steps you can repeat and improve. This is the kind of thinking you'd expect after centuries of mathematical trial and error. Yet there it is, in the earliest Sumerian tablets, as if the method was simply handed down, already finished. Part of the starter pack the Anunnaki left behind when they set up the world's first measurement system. And it wasn't just square roots. Sumerian tablets are packed with tricks for compound interest quadratic equations, finding the volume of odd-shaped objects, each one neat, efficient, and accurate. Their math wasn't rough or half-baked. It was polished. Later civilizations, when they stumbled across these formulas, realized there was nothing left to fix. The Sumerians had already figured out the best way to handle these problems, and they did it using base 60. Which actually makes the math cleaner than our base 10. Dr. Alina Robson, who spent years digging into Mesopotamian mathematics at University College London, published a study in 2008 that quietly rocked her field. She showed that math education in Sumer was the same everywhere. Kids in memorized the same multiplication tables as kids in Nippur. Same sequence of lessons, same kinds of problems, same examples. That kind of uniformity means someone designed the curriculum and made sure the entire civilization stuck to it. So who put this system in place? The tablets themselves point to Nisaba, the goddess of scribes. She said to own the Lapis tablet, a symbol of unchanging, eternal knowledge. Before they started their lessons, students prayed to Nisaba, asking her to open up the house of learning and share her secrets. They weren't hopping to discover something new. They wanted access to knowledge that already existed, perfect and complete, somewhere in the divine realm. That's a key difference. If people built mathematics piece by piece, you'd expect to see dead ends, rival methods, gradual improvements. But if math is handed down, revealed, not invented, it shows up fully formed and people just preserve it, afraid that changing anything might break the connection to its sacred source. Sumerian math looks revealed. No evolution, no competing systems, just careful transmission. And it's so well designed that 5,000 years later, we still use their methods to measure time and divide circles. But before we follow those instructions written in the stars, we need to see how the Anunnaki wove their knowledge into more than just tablets. It's there in the architecture, the ziggurats rising out of the Mesopotamian plains. These weren't just temples. They were math made solid, base 60 thinking you could climb. Stand at the foot of Ur's ziggurat, the huge stepped pyramid for the moon god Nana, and the first thing that hits you is the sheer size. It towers over 20 meters high, its corners lined up perfectly with the cardinal directions, surveying skills you wouldn't expect from the ancient world. But the real genius is in the measurements. The base is a rectangle, 62.5 meters by 43 meters. Those numbers aren't random. They're clean ratios in base 60, sexagesimal proportions, baked into the bricks themselves. Back in the 1920s, when Leonard Woolley started digging up Ur, he didn't just shovel dirt and call it a day. He measured every inch of the ziggurat, height, width, every terrace, you name it. His colleague, architect Hamilton Darby, took those numbers, and honestly, what he found still keeps architectural historians up at night. Every major proportion in that ziggurat lines up with ratios from Sumerian math tablets. The way the base relates to the first terrace, how each level stacks on the next, even the balance between horizontal and vertical, all of it follows harmonic intervals. The same math that shapes musical scales. This isn't some random accident. The Sumerians wrote about it. They said their buildings embodied the ME, divine laws, and at the heart of that was a belief. Cosmic order shows up as number, as ratio, as the kind of elegant proportions you get from base 60 math. So a ziggurat wasn't just a fancy stage for ceremonies. It was a mathematical model of the universe. Each tier stood for a celestial sphere. Each proportion, a bit of encoded astronomical knowledge. The whole alignment followed instructions the Anunnaki supposedly handed down for making sacred space fit the cosmos. Then there's Enki in Babylon, the place Greeks called the Tower of Babel. That one took the same idea and pushed it further. Archaeologists found foundation tablets that say its base was 300 cubits on each side, a perfect sexagesimal number, nice and cleanly divisible by 60. Its height, also 300 cubits, so you've got a 1-to-1 ratio between earth and sky, flat ground and the climb up to heaven. The thing rose in 7 tiers, each one shrinking, each exactly 7/12 the size of the one below. 7/12. You don't find that ratio anywhere else in architecture, but it pops up all over Sumerian astronomical tablets, always as the relationship between certain planetary cycles. This wasn't just building for the sake of building. It was astronomy in brick and mud, celestial mechanics turned into architecture. The texts credit Enki's wisdom for these proportions, say the ME demands sacred buildings keep in sync with cosmic order. Fast forward to the 1990s. Dr. Margaret Whitney Foster, an archaeoastronomer at the University of Chicago, did her own digging, this time into the angles of the Ur ziggurat staircases. She found they line up exactly with the angle of the ecliptic, the tilt of Earth's orbit compared to the celestial equator. That's about 23.5 degrees, the angle that sets the sun's path through the zodiac, the swing between summer and winter solstices, the heartbeat of the seasons. The Sumerians built that angle into their most sacred structure. Not close, not pretty good, exactly. They measured the ecliptic with a level of precision that humanity wouldn't hit again until the Renaissance. They locked it into their ziggurat, chalked it up to Anunnaki wisdom, knowledge that, they claimed, came before humans even had cities. Foster's paper, which ran in the Journal of Near Eastern Studies, argues that ziggurats worked as astronomical instruments, huge stone calendars where priests could track solstices, equinoxes, and planetary movements just by watching how sunlight hit a corner, or where shadows stretched on certain steps at certain times of year. That changes everything about how we see these places. They weren't just temples for superstitious rituals. They were observatories, calculation tools, three-dimensional textbooks teaching the link between geometry and the stars, between what you can measure on Earth and what plays out in the sky, and every calculation in their design. All base 60, the math the Anunnaki supposedly passed down before the world got wiped clean and had to start over. Meanwhile, tucked away in a climate-controlled vault at the British Museum, there's a collection of clay tablets most people never see. These are the astronomical diaries, 7 centuries of Babylonian observers tracking planets, eclipses, comets, even the first appearance of certain stars. The entries sound dry, almost bureaucratic, just dates, sky events, sometimes a note about the weather. But when you step back and look at all those records together, across the years, a pattern jumps out, one that honestly shouldn't even be there. These observers weren't just jotting down what they saw in the sky. They built models, real predictions, not just notes. They figured out what should happen, checked it against what actually happened, and tweaked their calculations when things didn't line up. It's the scientific method in action, except these folks were doing it 2,000 years before Francis Bacon showed up with the rulebook. And their math. All built on base 60, a system so slick and flexible it almost feels custom-made for astronomy, right up there with the stuff we use in modern software. Take tablet BM 45728. This one tracks lunar eclipses over 18 years. The calculations aren't basic. They factor in the moon's wobbly elliptical path, the shifting length of its months, and even the slow drift of its orbit where it crosses the sun's path. These are tiny, tricky details that demand years of watching and some serious number crunching. Yet when we check their predictions with today's software, the eclipses line up within hours. That's not luck. So how did they pull this off? Most people say it's just the result of patient, generational sky watching. Babylonian astronomers watched, took notes, and built their models bit by bit. But the tablets themselves hint at something else. They talk about even older records, ancient observations, and methods handed down from the days of Anu and Enlil. These models weren't invented on the spot. They were inherited, copied, and passed along because they worked. They were so solid, nobody felt the need to change them, just keep them safe. Dr. John M. Steele, who spent years poring over these tablets, says Babylonian lunar theory is right up there with the best of ancient math. Think Greek geometry or Chinese algebra. But hear what bothers him. The theory shows up fully formed. From the earliest tablets, it's already complex. There's no baby steps, no evolution from simple to advanced. It looks like they got it from somewhere else, some lost tradition we don't know about. And that tradition, the tablets point straight back to the Anunnaki. Anu, the sky god who set things in motion. Enlil, who made the calendar. Enki, who supposedly revealed the math behind how everything moves. These aren't just pretty names for decoration. They're the original credits, an admission that this knowledge came from beyond the current generation, from teachers lost to time. Then there, Venus. If you think the moon is tricky, Venus is a puzzle even modern astronomers call chaotic. It swings from morning star to evening star, vanishing behind the sun and coming back, following cycles that don't settle down into something neat or easy. Predicting Venus means tracking how it lines up with both the Earth and the Sun, all moving on their own paths and speeds. The Venus tablets of Amisajuka pull this off. They follow Venus for 21 years, logging every appearance and disappearance. Their dates match up with what we calculate today. That 21-year stretch isn't random either. It's the magic window where Venus's 584-day cycle finally syncs up with the solar year, repeating in a pattern you can actually use. To spot this, you'd need either a long line of sharp-eyed observers or some serious computational chops. The tablets themselves say this knowledge goes back to before the flood, rescued from disaster, guarded by scribes who treated every number like scripture. They copied, never changed, afraid to lose even a scrap of it. And everywhere you look, it's base 60, handled with the kind of ease that makes you wonder if the whole system was built just for this, tracking cycles within cycles, as if the people behind it understood exactly how much you can do with a number that divides so cleanly. Look up at the night sky, and you're staring at almost exactly what the ancient Sumerians saw. Same stars, same constellations, same bright planets wandering against that fixed backdrop. The moon still waxes and wanes through its month, just like it did thousands of years ago. But here's the thing. When Sumerian astronomers looked up, they saw more than just twinkling lights. They saw instructions, something we've mostly forgotten how to notice. Their star catalogs, which later Babylonians copied, list out constellations along the ecliptic, the sun's yearly path across the sky. They divided that path into 12 sections. Each section lined up with a constellation: the bull, the twins, the lion, the virgin, the scales. You recognize these names. They're the zodiac signs we still talk about. The Sumerians didn't make up the zodiac, though. They just wrote it down, saying they got this knowledge from even older sources, or from the Anunnaki before the flood. Each zodiac constellation claimed 30 degrees of the ecliptic. So, 12 constellations times 30 degrees. That's a neat 360 degrees, a full circle, and a mathematically perfect way to slice up the sky. This system let astronomers plot the heavens using coordinates that fit nicely with base 60 math. Right ascension, the sky's version of longitude, gets measured in hours, minutes, and seconds, all in sexagesimal units. Declination, think latitude, is in degrees, arcminutes, arcseconds. The whole celestial mapping system traces back to Sumer, inherited from the Anunnaki Right-S instructions. But the zodiac's not just a map grid. It hides deeper math, the precession of the equinoxes, the slow wobble in Earth's axis that nudges the sun's spring equinox spot backward through the zodiac. This shift happens at about 1 degree every 72 years. Complete precession, about 25,920 years, what the Sumerians called the Great Year. And 25,920 divides smoothly into 12 ages of 2,160 years each, one for every zodiac sign. Each age is 36 centuries. Again, tidy multiples of 60. Did the Sumerians actually notice precession? The standard answer says no. Precession's so slow, you'd need generations of careful skywatching to spot it. The Greek Hipparchus gets credit for the discovery around 150 BCE. But then you find these Sumerian tablets over 2,000 years older, mentioning the Great Year, the shifting houses of heaven, and cycles of 25,920 years. They weren't supposed to know any of this. Unless, maybe, they got it from someone who did, their records echoing knowledge gathered by skywatchers across centuries, encoded in base 60 math, preserved even if they didn't totally get what they were copying. But it wasn't just astronomy running on base 60. In the ruins of Lagash, archaeologists dug up a different kind of tablet, one that shows just how deep sexagesimal thinking ran in Sumerian life. This one, cataloged as HS 201, is a medical prescription from about 2200 BCE. It lists a recipe for treating respiratory infections, plants, how to prepare them, and most interestingly, dosages, each measured in base 60 units. Here, what it says: 1/60th of a mina of dried thyme, 3/60ths of a mina of crushed pine resin, and 7/60ths of a mina of fermented barley extract. Mix it all with honey, take it twice a day. The mina was their unit of weight, about 500 grams, so 1/60th's around 8 grams. These aren't vague instructions like a pinch of this, a handful of that. They're precise, calculated pharmaceutical doses. Modern researchers have broken down the ingredients from these tablets. Thyme brings thymol, a strong antimicrobial. Pine resin's got terpenes that help clear up lungs and cut inflammation. Fermented barley, it soothes coughs and helps you breathe easier. These Sumerian prescriptions weren't guesswork or superstition, they actually work. And when you translate their doses into modern terms, they land right inside the safe, effective ranges confirmed by today's clinical research. So how did the Sumerians figure out the right dosages? Medicine doesn't just fall from the sky. People learn by trying things, making mistakes, and figuring out what actually works without hurting anyone. You'd expect to find signs of all that trial and error, clay tablets with half-baked cures, warnings about what not to do, maybe notes on what went wrong and how they fixed it. But the Sumerian medical texts, they don't show their work. Instead, they lay out the recipes as if they're already tried and true, handed down by Ninisina, their goddess of healing, who supposedly revealed the medical ME, the blueprint for life and knowledge, to humanity. The formulas show up already polished, measured out in base 60, just as precisely as they tracked the stars or built their temples. Dr. Markham J. Geller over at University College London has spent years digging into these ancient tablets. He argues the Sumerians knew a lot more than people once thought. He found that their doctors could tell the difference between something short and sharp and something chronic. They changed doses for kids versus adults, considered body weight, and even mixed their medicines in ways that today we know make the ingredients work better together. That's not luck, that's real medicine. To pull this off, you need real experimentation, solid record keeping, and the math skills to scale everything just right. And all of it, every measurement, every calculation, runs on base 60, the same number system they used for tracking planets and planning buildings. It looks like whoever created the medical ME, whoever started these formulas, saw all these fields as part of the same logical universe, all supposedly revealed by the Anunnaki, those ancient gods who, according to the texts, understood everything before humans even got started. Their math even shaped how they thought about the body. In their medical texts, you see them describing the body in ratios. Elbow to fingertip, that's a cubit. Shoulder to elbow, another cubit. Top of the head to the soles of the feet, 7 cubits. These aren't just random measurements. They're the same proportions Da Vinci would sketch 2,000 years later, the famous Vitruvian Man, showing that the body itself follows mathematical rules. But the Sumerians went further. They tied these body proportions right back to base 60. They calculated how organs take up certain fractions of the body, how blood vessels branch off in sexagesimal patterns, even how the pulse ticks in 60ths of an hour. In their view, the same math that charts the planets also runs through our veins. Everything from the stars to the human body fits into the same cosmic blueprint, the ME, set down by the Anunnaki. And then there's music. Tucked away in the Penn Museum's archives, there's this clay tablet, CBS 10996, dating back to around 1800 BCE. For years, nobody knew what to make of it. But eventually, someone cracked the code. It's a set of tuning instructions for a 9-string lyre, written in what we now recognize as musical notation. The numbers spell out the same intervals modern musicians call the Pythagorean scale. We're talking simple ratios for pure sounds, 2-to-1 for the octave, 3-to-2 for a perfect fifth, 4-to-3 for a perfect fourth. These are the intervals that just sound right to our ears because they line up with how real strings vibrate and blend together. But spotting those relationships takes either a sharp musical ear or a head for math. Turns out, the Sumerians had both, and again, they wrote it all out in base 60. Why does that matter? Because music is all about ratios, and base 60 lets you slice and dice numbers almost any way you want. Want to split a string into thirds, fifths, or sixths? It's easy in base 60. You can write out even the more complicated intervals, like a major third, 5-to-4, or a minor sixth, 8-to-5, with whole numbers that break down neatly. The music and the math just snap together, almost like someone designed them side by side, with a deep understanding of both sound and numbers. And honestly, we're still catching up. Back in the 1990s, Richard Crocker, an American musicologist at the University of California, took a close look at Sumerian musical tablets and stumbled on something that still sparks arguments today. He realized that certain temple hymns weren't just random poems with musical accompaniment. These hymns actually built metrical patterns, the rhythm and stress of syllables, directly into their structure, and those patterns matched up with the same mathematical ratios the Sumerians used for tuning instruments. In other words, they wrote their poetry and melody as two sides of the same coin. Both followed the same base 60 math that ran through everything in their world. Take a hymn to Ishtar from Nippur. The text breaks into neat chunks of 60 syllables, with lines of 12, 20, or 30 syllables inside, every number a clean division of 60. Crocker tried to reconstruct the melody using the ratios found in other musical tablets, and it all lined up. The places where the verse naturally paused, where the music settled, where the stress fell, they matched up with the points where the melody would resolve. You can see the same math that designed their ziggurats, predicted eclipses, and measured out medicine right there in the poem's bones. So what does this tell us? The Sumerians, and if you believe the stories, the Anunnaki who taught them, didn't treat math as some distant, abstract tool. For them, it was the very language of reality. Math explained the stars, the buildings, the medicines, and the music. Everything was connected, running on the same set of proportions, all written in base 60. This system pulled the curtain back, showing how everything, sky, earth, body, music, fit together in one grand harmony. Picture yourself inside a Sumerian temple at dusk. Priests chant hymns, their voices weaving through melodies set to Pythagorean intervals, the words falling into 60-syllable blocks. The music sticks to simple ratios, 3-2, 4-3. Outside, a 7-tiered ziggurat rises, each level built with the same harmonic math. Above, constellations arc across the sky in 30-degree slices. In the healer's room, someone measures out medicine in 60ths. Every sight, every sound, every single measurement is part of this deep, unified system. The base 60 math the Anunnaki supposedly gave them as the blueprint for civilization. But if you want something really practical, look at what this math did for navigation. With base 60, the Sumerians didn't just measure time and space in theory. They figured out how to actually find their way across deserts and open water, places with no obvious landmarks. These people, who lived thousands of years before the European explorers, knew how to calculate their position and plot a course with startling accuracy. There's a plain clay tablet in the Vorderasiatisches Museum in Berlin, labeled VAT 7847. Most visitors walk right past it, but this tablet from around 2300 BCE holds what modern scholars see as a route map, a set of instructions for traveling from Lagash to the Persian Gulf. And these aren't vague directions like head south until you hit water. They're precise, bearings in degrees from north, distances in Beru, about 11 kilometers each. It says from Lagash, go 120 degrees from north for 3 Beru to the canal junction. Turn 90 degrees east, then travel 2 Beru to the river crossing. That's not a guess. 120 degrees is exactly 1/3 of a circle, using a 360-degree system. To follow these instructions, you'd need to measure angles accurately right there in the field. The Sumerians did this by watching the stars, aligning their path with the rising points of specific stars, whose positions they'd already calculated and written down in base 60 tables. And their skills didn't stop at land travel. Another tablet from dating to about 2100 BCE, describes a maritime trade journey down the Euphrates to the Persian Gulf, along the shore to Dilmun, now Bahrain, on to Magan, the Oman Peninsula, and finally to Meluha, probably the Indus Valley. Each leg lists the distance in Beru, the direction in degrees. The route covers more than 2,000 kilometers, including stretches across open water where you can't see land at all. So how did Sumerian sailors actually keep their bearings on those long journeys? Well, they used the stars. Not so different from what European navigators did thousands of years later. Picture this. You're out on the water, no landmarks, just the night sky. The Sumerians measured how high the stars sat above the horizon with special tools, checked those numbers against star charts, and figured out their latitude from the difference. It sounds simple, but it hinges on 3 things: being able to measure angles precisely, having good tables that track where stars should be, and knowing the math to connect all the dots. The Sumerians nailed all 3. They built it all on their base 60 system, and according to their own stories, it was the Anunnaki who handed down this knowledge. Take Dr. Alina Robson at Cambridge. She really dug into Sumerian math and found that their surveyors used tools called jisheta, think measuring rods, and even what looks like an early version of the astrolabe, pieced together from old tablet descriptions. With these, they measured star angles, wrote the results in base 60 degrees and fractions, and made maps so detailed that other surveyors could copy them and keep everything consistent for generations. There's a map from Nippur around 1500 BCE that's basically an ancient city blueprint. Streets, buildings, walls, it's all there, marked out with real precision. But the wild part, it's got angular directions too, bearings to other cities measured in degrees from north. So it's not just a picture, it's a coordinate map. An early version of the latitude and longitude grid we use now, and it all traces back to that Sumerian circle sliced into 360 parts, a division they said the Anunnaki invented. Sumer wasn't alone either. Their system spread. Trade routes reached out to Egypt, the Indus Valley, Anatolia, and the Arabian Peninsula. Merchants needed common ground for distance and direction, a shared language of numbers. Base 60 math worked beautifully because it divides up so easily. As traders moved, they carried this math with them. Other cultures picked it up, not because they had to, but because it just worked better than what they had. Look at the Egyptians. When they built the pyramids around 2500 BCE, they lined them up with almost eerie precision, less than 1/10 of a degree off true north. How'd they pull that off? Astronomical methods that look a lot like the Sumerian ones. Some scholars think both civilizations borrowed from the same deep well, maybe from the Anunnaki themselves, who supposedly set up base 60 math before floods and disasters scattered humanity. Now swing over to the Indus Valley. These folks lived far from Sumer, but their cities, Harappa, Mohenjo-Daro, used standard weights and measures. Their math was mostly decimal, but their buildings, angular divisions, 360 degrees, just like Sumer. Their bricks followed a 4:2:1 ratio, exactly what Sumerian builders used. Maybe they traded ideas, or maybe they both inherited them from someone earlier. Even in ancient China, astronomers split the sky into 360 degrees, grouped stars into 12 zodiac sections, and used base 60 for calculations. Their legends talk about wise rulers before the floods, the kind of figures that sound a whole lot like the Anunnaki, ancient teachers who gave people the tools to build a civilization. So here's the real puzzle for anyone studying ancient astronomy. Why did cultures from Mesopotamia to Egypt to India and China all settle on the same 360-degree circle and the same base 60 subdivisions? The usual answer is that it just makes sense, that any smart culture would stumble onto it sooner or later. But you know what? 360 degrees isn't obvious. Neither is base 60. These things are choices. And when you see the same choice pop up on 3 different continents, you have to wonder if there's more to the story than just coincidence. Maybe they all picked up the system from teachers who came before their own cultures. Maybe the Anunnaki didn't just stick to Mesopotamia. Maybe they had a reach that spanned the whole world. Or maybe, after the Great Flood, survivors carried their knowledge to new places, rebuilding civilization with the same math that held the old world together. The Sumerian tablets are just the oldest written evidence we've found, but honestly, the ideas inside them go way back. Before writing, before cities, before that disaster split history in two. Jump ahead to an MIT lab in the early 2000s. A group of computer scientists, knee-deep in satellite navigation, hit a snag. As they worked on GPS algorithms using the usual base 10 math, little rounding errors kept popping up. The errors piled up and the system's accuracy slipped. Then someone, half joking, really, suggested switching the calculations to base 60. Just like that, the errors vanished. Turns out, sexagesimal math, thanks to how easily you can divide it up, handled all the messy spherical trigonometry way better than decimals. The results got sharper, and the computers didn't have to work as hard. None of the researchers realized they were retracing steps laid down 5,000 years before. They didn't know the Anunnaki had already figured out that base 60 is perfect for measuring out a sphere. Whether you're tracking stars or satellites, navigation just works better when you measure angles with a system built for easy division. Today, GPS satellites do their math in binary, but spit out coordinates in degrees, minutes, and seconds. The same format Sumerians used to map their world long before anyone dreamed of electricity. That's what I mean when I say we're still following the Anunnaki's blueprint. Modern engineers, oblivious to the names Enki or Nisaba, keep landing on the same solutions those ancient texts call divine gifts. Not because anyone's dusting off clay tablets, but because the problems themselves haven't changed, and base 60 is still the best answer. Try dividing a circle better than 360 degrees. Try picking a number more flexible than 60. The system just works. It's worked for 5,000 years. Every time someone tries to scrap it, they end up back where they started. The Anunnaki simply got it right. Night falls over the old cities of Sumer. The ziggurats are long gone. Libraries turned to sand, but the math never left. GPS satellites circle above, counting time in base 60 seconds, pinning down locations in base 60 degrees. Ships at sea still steer by the same coordinates Sumerian traders used. Astronomers chart the stars with right ascension and declination, using sexagesimal coordinates straight from ancient Mesopotamian star maps. The instructions are still running. The knowledge survives. And for all our advances, we haven't found a reason to ditch the system the Anunnaki set in motion before we had a word for history. There's a clay tablet from Ashurbanipal's library. He was the Assyrian king who gathered texts from all over Mesopotamia in the 7th century BCE. At the end, the scribe left a note, copied from an ancient tablet. Let no one alter it. It's an astronomical table predicting Jupiter's path over 19 years, accurate to within a day. But that note says more than numbers ever could. It's anxious. The scribe worries someone might change the text, fix what looks wrong, try to improve the instructions. He forbids it. The old tablet has to stay as it is, not because it's flawless, but because it's ancient, because it ties the present to a source of wisdom we can't afford to lose, because the instructions come from people who, in some ways, knew more than we do now. That kind of respect for the ancients runs through all Mesopotamian astronomy. Babylonian scholars in the first millennium BCE didn't pretend they were making anything new. Instead, they said they were recovering old observations, cross-checking different archives, patching up copying errors, and putting the original math back together. They saw themselves as caretakers of the Anunnaki's legacy, not trailblazers trying to outdo it. Still, those ancient calculations actually work. When modern astronomers first dug into the old Babylonian planetary tables in the 1800s, they couldn't believe the accuracy. The predictions for Mars's retrograde motion, Venus's appearances, the eclipse tables that stretch across centuries, they all hold up. These folks built working models, and they managed it about 2,000 years before Newton came along. How did they pull it off? The textbook answer is patient observation, years of watching the sky and tweaking formulas as they went. Babylonian astronomers, one generation after the next, kept records and built up their ability to predict. But if you look at the tablets themselves, that story doesn't quite add up. They don't talk about slow, steady progress. What you see instead is a process of recovery, copying older texts, consulting the data from Anu and Enlil. Their names aren't just religious window dressing. They're cited like authors in a research paper. Anu and Enlil made observations. Sumerian astronomers checked their work. Babylonian astronomers copied those Sumerian copies. The chain keeps going back, further and further, until you hit figures who aren't even really human anymore. Keepers of knowledge that seems to show up fully formed, before people even claim to have discovered it. Take Taurus, the bull. There's this tight little cluster of stars there called the Pleiades. Most people just see 7 of them, the 7 sisters, but a good telescope shows a whole crowd. The Sumerians called them the 7 judges, and they were crucial for farming. When the Pleiades rise at dawn in late spring, it's time to start harvesting. When they set at dusk in the fall, you know winter coming. That's practical astronomy, a calendar written in the sky. But Sumerian farming texts don't just say, "Hey, watch for the Pleiades." They give the exact day tied to the sun's spot in the zodiac, when the Pleiades first reappear in the pre-dawn sky after hiding behind the sun for weeks. To figure out those dates, you need to know the difference between the solar year, 365.25 days, and the sidereal year, which is the time it takes the stars to get back to the same spot, about 365.256 days. It's a tiny difference, but it adds up. Over centuries, the calendar slips. If you want to predict heliacal risings accurately, you need records that stretch across generations and some real mathematical chops to account for the drift. The Sumerian almanacs nailed it. Their calculations weren't just ballpark guesses, they were spot-on. Modern astronomers checked with computer models, and the Sumerian dates lined up. Yet even with all that, the almanacs credit this knowledge to Enlil, the god of seasons and storms. Supposedly, he set the agricultural calendar before the flood hit. The instructions aren't from recent observations. They're inherited, handed down from a time when someone had already measured out the relationship between the sun, the stars, and the seasons, wrapped it up in base 60 math, and left it for future farmers to use without having to do the work all over again. That's the real heart of the Anunnaki instructions. Knowledge so tight, so perfectly matched to how nature works, it doesn't need updating. No one tries to improve base 60 math, or mess with the 360-degree circle, or change the 24-hour day. These systems have stuck around for 5,000 years because they work, not just out of habit, but because they fit reality in a way nothing else does. Every time someone tries to swap them out, decimal time in the French Revolution, metric angles, new calendars, it fails. We keep coming back to the Anunnaki system because it's not random. It's brilliant. It's as close to perfect as we've ever gotten. Now just imagine for a second that the Anunnaki weren't just gods in old stories, but an actual civilization, a people who figured out advanced math and astronomy before disaster wiped them out. The flood really happened. You see it in the mud layers all over Mesopotamia. It smashed their cities, drowned their archives, scattered the survivors. But before the water swallowed everything, they did what they could. They pressed their knowledge into clay tablets, the most durable thing they had. Millions of them. Math tables, star charts, building plans, planting calendars, a blueprint for putting civilization back together. When the floodwaters finally pull back, the survivors crawl out into a shattered world. They scavenge whatever's left. In the rubble, they find tablets ancient, covered in strange symbols. They copy what they can, not really understanding all of it, but they know it matters. This knowledge is rare. They set up schools, determined to keep the old mathematics alive. They rebuild temples right where the old ones stood, lining them up by the stars, using the same proportions as before. The people who left these instructions, they call them the Anunnaki, the ones who came down from the sky. And over time, as stories blur and people forget, the Anunnaki stop being just ancestors. They turn into gods, legends wrapped in myth. But the instructions themselves stick around. Base 60 math, too handy to let go. The zodiac, it just works for mapping the sky. Dividing the circle because you can't navigate without it. Measuring time in 60ths because it fits perfectly with how the stars move. These aren't just old beliefs you debate over dinner. They're tools. They work. And every civilization that survives keeps them. Because losing that knowledge means stumbling in the dark for centuries, maybe forever, and probably never doing it better. Most academics see the Anunnaki as pure myth, symbols for the wind, the sun, maybe some long-dead kings. But you have to wonder, why do these stories paint the Anunnaki as teachers, not gods who create worlds out of nothing? Why do they hand down knowledge instead of just inspiring it? Why does every text talk about restoration, not invention? Here's the thing, the Sumerians couldn't believe their grandparents came up with all this. Their math was too sharp, their astronomy too spot-on, their buildings too exact. So they looked for a reason, and over they landed on one answer: inheritance. The Anunnaki started it. The flood broke the chain. They salvaged what they could, and those instructions, they're still running the show. They're how we tell time, how we map the earth, how we chart the stars. Picture this. In some dusty museum back room surrounded by gadgets and foam padding, there's a Sumerian math tablet. If you could hold it, you'd feel the cool, gritty clay. On the surface, a multiplication table, 60 times 1, 60 times 2, and on up to 60 times 60. 3,600 the SAR. Run your finger over those marks, and you're tracing the same system you use every time you check your clock, plan a route, or count seconds ticking away. That tablet is about 4,000 years old. The person who made it, long gone. Their city's a pile of stones. Their words have faded into silence. But the numbers are still here. The instructions remain. Every time you glance at your watch, you're reading a message that started with the Anunnaki, passed down through 5,000 years, still ticking, still true, still quietly ruling your day. So maybe the real legacy of the Anunnaki isn't some crumbling monument or half-remembered myth. It's math. It's systems. Maybe their instructions weren't for worship. They were for use, for keeping, for passing on. Maybe they understood that stone wears down and cities collapse, but a solid measurement system, once it's part of daily life, is almost impossible to kill. The Sumerians had a word for this kind of immortality: me. Not a soul floating off after death, not some ghost. Just knowledge that outlives its makers. Principles so basic you stop seeing them, woven so deep into civilization that, if you try to pull them out, everything would fall apart. The ME of math, the ME of astronomy, the ME of timekeeping. These aren't flowery metaphors. They're the real operating codes. And if you ask the Sumerian texts, they didn't come from us. They were handed down, taught, inherited from the Anunnaki, who had them long before humans were here to use them. You can shrug this off as just another myth. Maybe you think the Sumerians came up with base 60 on their own and just credited the gods because they didn't realize how clever they were. But honestly, that means you have to believe a Bronze Age society, with no obvious warm-up, suddenly invented the slickest number system in history, rolled it out across dozens of cities, and kept it so consistent that 5,000 years later, we're still using their way to track time and measure angles. Or, you could look at it differently. Maybe the Sumerians were exactly what they said they were: keepers of something older, protectors of knowledge passed down from teachers whose civilization was already ancient when Sumer was brand new. Maybe the Anunnaki weren't magical beings, but real people. People whose math and astronomy were so advanced for their era that later generations could only keep their memory alive by turning them into legends. The instructions survived, the teachers didn't. Now, thousands of years later, we still follow those instructions, even though we've forgotten where they came from. We use base 60 for our coordinates. We live our days by sexagesimal hours. We break circles into 360 degrees. Why? Because someone, long before anyone was writing history, pressed these numbers into clay and said, "This is sacred. Don't change it." Think about those quiet hours before dawn, when the world feels still and time seems to thin out. All over the globe, astronomers get ready to observe the sky. They set up their telescopes, measuring angles in degrees. They track time in hours, minutes, and seconds. They plot stars using coordinates based on this ancient system. Every number, every division, every calculation, they're still working with the same framework the Anunnaki gave to the Sumerians more than 5,000 years ago. Most of these astronomers have never heard of Enki or Nisaba. They've never read the Sumerian king list or cracked open the ME, but they follow those ancient instructions anyway. They don't even think about it. The rules are so baked into the way science works that questioning them feels as weird as doubting gravity. And maybe that's the whole trick. Maybe the Anunnaki realized that knowledge only survives disaster if it becomes habit, if it gets woven so tightly into daily life that even when everyone forgets where it came from, the pattern still sticks. You don't need to know why there are 60 seconds in a minute if every clock shows you the same thing. You don't have to understand why a circle has 360 degrees if every compass and map just expects it. The system survives because we keep using it. This isn't the kind of immortality we usually imagine. It's not about saving names or memories. It's about preserving a pattern, a structure. Those elegant relationships the Anunnaki found in the sky, locked into a system so useful that humanity never let it go. 5,000 years is a long time. Empires have come and gone, languages have died, inventions have risen and fallen, but base 60 is still here. The sexagesimal system still works. The old instructions are still running. Every time you check the clock, you're part of an unbroken line that stretches all the way back to the first Sumerian scribe, copying tables from something even older, saving knowledge from before the flood, before cities, before people even thought to measure time. The Sumerians called this work sacred. They knew the knowledge wasn't really theirs. It belonged to the ones who came before. And their real job, the most important thing any scribe or priest or astronomer could do, was to pass it on, untouched and whole, so the chain never broke. And it still hasn't broken. The instructions the Anunnaki left behind, whether they were gods, ancestors, or just the last survivors of some vanished pre-flood world, are still running the show. They're still the framework for how we measure the universe. Their system hides in every scientific tool, every GPS satellite, every star chart. We like to think we've moved on from ancient wisdom, right? That we've outgrown it. But honestly, we're still working with their numbers, still following their rules. We divide time and space just like they taught the Sumerians to do it. 5,000 years ago, back before writing, before history, before we even pretended to know where we came from. Think about it. Every time you check the clock, use a compass, or glance at your phone's map, you're obeying instructions you never signed up for. What if the Anunnaki's real triumph wasn't building cities or temples, but designing a system so airtight that, no matter how many times civilization falls apart, people keep rebuilding everything on the same blueprint? Over and over, after every collapse, every disaster, every flood. Go stand outside on a quiet night under stars that barely budged since Sumerian astronomers first mapped them. The ruins of Eridu are still out there, poking up through the sand. The old temple of Enki is gone, just dust now. The library that once held the oldest tablets vanished, but the knowledge, still around, not in the stones, but in you. In the way you chart your day, in the geometry you learned in school, in the coordinates astronomers used to map galaxies. The Anunnaki didn't bother carving monuments to survive the ages. They left instructions that became time itself. And as long as we measure hours in 60s, carve circles into 360 degrees, and navigate by sexagesimal coordinates, their system keeps humming along unseen, but absolute. Those ancient clay tablets still whisper, patient and relentless. This knowledge was given, they insist, from a time before memory, not to be changed. And we haven't really changed it. We've built on top, sure. We crunch numbers on computers now instead of clay, but the base is the same. Base 60. The perfect number. The Anunnaki's gift. Maybe that's the real puzzle here. Not whether the Anunnaki were real, but why we stopped asking where our deepest assumptions spring from. Why 60 for time? Why 360 for a circle? Who decided we'd slice up space this way? The instructions have turned invisible, and invisible knowledge is the strongest kind. It doesn't need to shout. It shapes what's possible without anyone noticing. It keeps going, even after everything else falls apart, because people still need to measure time and space and the stars. When the world ends, the survivors reach for what works, the old ways, the trusty systems, the instructions that survived the last disaster. The Anunnaki, whatever they were, gods or people or something stranger, got it. They tucked their knowledge into the most indestructible form they could, not in stone which crumbles, not in stories which drift. In math, hidden in daily habits, reinforced by usefulness, passed down every time someone measures the world. So tonight, as you fade towards sleep, As your breathing slows and your mind quiets, think about the numbers that shape even your rest. The hours you need, the minutes until your alarm, the temperature in your room. All of it, every division, traces straight back to clay tablets pressed in ancient Mesopotamia by scribes who believed they were copying the words of gods. Maybe they were. Maybe they were just copying the work of some lost, extraordinary civilization. Or maybe it doesn't matter. What matters is the instructions survived. 5,000 years later, we're still following them. The Anunnaki's math has outlasted every empire, every faith, every new technology, and we're still living by it. The numbers are still with us. 60 seconds, 60 minutes, 360 degrees. They're everywhere, dividing up our days, mapping out space, steering us through a universe the Anunnaki measured in base 60 long before the Sumerians even claimed civilization. We like to think the Sumerians started it all, but honestly, they just picked up where someone else left off. Same as us. We're still following those old instructions, still slicing up time in circles the way they did, still obeying a mathematical order set by people who vanished before history even got going. Out in the desert, wind sweeps over what's left of Sumer, picking up grains of dust that, who knows, might have once been a cuneiform tablet. Under all that sand and memory and forgetting, the numbers are still there. Waiting, patient, flawless, eternal. The Anunnaki's last message, and we're all still listening, even if we don't realize it. Want to know how deep this runs? Step into the Adaba, the tablet house. This is where every Sumerian scribe spent years, not just learning to write, but learning to think in base 60. This wasn't just a school. It was a machine for transmitting the ME, the blueprint of civilization, from one generation to the next. The Anunnaki's knowledge wasn't just preserved. It was drilled in until everyone who mattered could calculate in sexagesimal without even thinking about it. Picture yourself as a kid, maybe 10 years old, in the Adaba at Nippur around 2000 BCE. Your family's got money, your father trades goods, maybe manages temple accounts. He needs someone to carry on, so here you are, up before sunrise, chewing on bread and dates, walking through those tight streets to a mud brick classroom near the temple. Inside, it's dim, sunlight slanting in from high windows. The room's full of kids, all cross-legged on the floor, each one with a wooden board and a lump of clay. At the front, the Ummiyah, the head teacher, isn't the sort to let mistakes slide. Shelves behind him groan with hundreds of tablets, the perfect examples you'll copy again and again, until your hands know the shapes without your brain getting in the way. Today's lesson, multiplication tables. Last year you drilled the basics, 1 times 60, 2 times 60. Today it's 60 times 60. SAR number, stuff that controls the stars and the size of fields. The Ummiyah calls out questions. You press your reed into the clay. 60 times 60 is 3,600. 60 times 61, 3,660. And on it goes. But it's not just about memorizing. You're learning to see the world in base 60, to slice up time and space and volume and area the way Enki supposedly taught, back when the Anunnaki themselves were walking around. The Ummiyah says these numbers are sacred. Get it wrong, and it's not just a bad grade, you've messed up something divine. The ME has to stay perfect. The old tablets can't be changed. After 4 hours, your hand is stiff and your back sore, but there's no break. Next up is geometry. The Ummiyah sketches a circle. How many degrees? You hear, and you don't even have to think. 360. 1/6, 60 degrees. 1/12, 30. Every answer clicks into place, the system so neat it feels inevitable. Then astronomy. The Ummiyah brings out a tablet with star maps, copies passed down for centuries. He shows you the ecliptic, the sun's path through the sky, and points out how each zodiac sign takes up exactly 30 degrees. Now you're doing real calculations. The sun's at 15 degrees in the bull, he says, and it moves about 1 degree each day. How long until it reaches the twins? You know the bull covers 30 degrees, so the answer's easy. 15 days to go. It's all there: time, space, the stars themselves. The numbers don't just measure the world, they shape how you see it. This isn't just academic busywork. You're learning how to read the sky, when to plant barley, when the river will flood, when to hold the next festival. The Adaba is shaping you into someone who keeps civilization running, where everything, sacred calendars, temple rituals, even the city's daily life, depends on getting the stars and numbers right. The priests expect you to know this stuff cold, to predict celestial events months ahead, all using that complex base 60 math. But the real secrets come later. In your final years, the Ummiyah unlocks the chests and hands you the old tablets, the guarded ones, the kind only masters touch. These tablets are the core of everything. Anunnaki calculations, original records of planetary cycles, eclipse formulas, the sacred ratios for temples that sing with the cosmos. You copy them, hands shaking, terrified that even the tiniest slip could ruin knowledge that survived floods, wars, fire, centuries of chaos. One tablet hides a hymn to Nisaba, goddess of scribes. It sounds like poetry, but tucked inside are math ratios and harmonic intervals. The Ummiyah points this out. The old masters hid knowledge everywhere, so if calculation tables disappeared, someone could rebuild them from hymns. If the hymns vanished, temple blueprints still carried the secrets. The ME weren't left to chance. They multiplied them, weaving them into every part of the culture. Dr. Nick Veldhuis at UC Berkeley has spent years digging through thousands of student tablets. He found Sumerian schooling was shockingly uniform. It didn't matter if you studied in Nippur, or Uruk. You learned the same texts, in the same order, with the same teaching tricks. It's clear someone at the top wanted every scribe to absorb base 60 thinking so deeply they'd pass it on without even trying. The sameness ran deep, even the mistakes. Veldhuis found some errors keep popping up in tablets from different places in centuries. The same botched cuneiform sign, the same slip in a standard math problem. Students weren't just copying lessons, they were copying the model tablets exactly, right down to the errors. The point wasn't perfect understanding, but perfect transmission, keeping a chain unbroken all the way back to the originals. The ones the Anunnaki supposedly carved before humans even picked up a stylus. This way of teaching had a cost. Sumerian math barely changed for 2,000 years. Tablets from 2500 BCE show the same calculations you'd find in 500 BCE. While Greek thinkers made new proofs and Chinese mathematicians figured out negative numbers and decimals, Mesopotamian scribes just kept copying the same tables, working the same problems. They didn't chase innovation, they worshipped preservation. But honestly, preservation worked. Archaeologists dig up Mesopotamian sites and find math that still works, astronomy that still predicts, buildings that haven't fallen, medicine that still has power. What looks like stagnation is actually careful cultural engineering, a strategy to protect knowledge through every collapse and conquest. As long as one scribe somewhere kept the Adaba tradition alive, the base 60 system survived. And it really did survive. When the Akkadians took over Sumer around 2300 BCE, they kept Sumerian math. The Babylonians, 1,000 years later, kept the scribal schools going. Same base 60, same old methods. The Assyrians built libraries and collected the ancient tablets, saving Sumerian mathematical texts for 2,000 years after the language itself vanished. The instructions outlasted the civilization because they were designed to. They got buried so deep in daily life that pulling them out would V brought down the whole system. The Adaba is long gone. The Ummiyah, those ancient teachers, sleep under ruins nobody visits anymore. Nisaba gets no more offerings. Still, if you walk into any elementary school, whether it's in the US, Europe, or Asia, you'll see kids learning to tell time in hours, minutes, and seconds. They split a circle into degrees. They count in 60s, not knowing this is a 5,000-year-old system, handed down by people who said they got it from beings called the Anunnaki. Today's classroom is just the Adaba with new paint. The teacher at the whiteboard, that's the Ummiyah right air, whether they know it or not. And those students, learning how to measure angles or plot coordinates or just read a clock, are following instructions that have echoed for 200 generations. Nobody explains where these ideas really come from. They just repeat them, which is exactly how Sumerian scribes kept the ME alive. Fast forward to the Jet Propulsion Laboratory in Pasadena, California. You've got NASA engineers laying out flight plans for Mars rovers, lunar landers, deep space probes. Their calculations are all about spherical trigonometry, figuring out positions on planets using degrees, arc minutes, arcseconds. They use software and computer chips that would look like magic to a Sumerian priest. But when you strip away the hardware, the math is the same. It's the Babylonians' Base 60 system, the one their priests used to track planets 4,000 years ago. When Curiosity landed in Gale Crater in 2012, its spot on Mars was mapped using coordinates that break the planet into 360 degrees of longitude and 180 of latitude, with north and south split into 90-degree pieces. Mars itself doesn't care about any of that. These divisions are completely human, a bit of Sumerian astronomy we slapped onto an alien world because, honestly, we don't have anything better. The Anunnaki S system still calls the shots. You see the same thing in your phone's GPS. Billions of people carry these gadgets, which talk to satellites orbiting high above Earth. Those satellites send out time signals accurate to billionths of a second, so your phone can figure out where you are by measuring how long it takes the signals to arrive. But when your phone tells you your location, it's in degrees, minutes, and seconds, sexagesimal coordinates, straight from ancient Mesopotamia. It feels like high-tech magic, but the math is 5,000 years old. Dr. Duncan Steele, an astronomer who's worked with NASA, wrote in his book Marking Time that Base 60 is one of history's greatest examples of path dependence. Once a system gets deep enough into our infrastructure, you can't really get rid of it. Sure, you could try decimal time, 10-hour days, 100-minute hours, 100-second minutes. The French actually tried that during their revolution. It flopped because every clock, every calendar, every astronomical chart would write, "V needed rewriting." Changing it just isn't worth the trouble. If the Anunnaki were real, and if they designed Base 60 to last forever, they pulled off a kind of immortality that outlives bloodlines or memories. They built something so useful and so perfectly matched to the way we measure time and space that giving it up feels impossible. Their system didn't survive through power or faith. It survived because the math just works. 60 is a hard number to beat. You don't improve on it. You just accept it and move on. Even in quantum physics labs, where scientists measure time in attosecons, billionths of a billionth of a second, they're still using the second as their base unit. And that second is defined as over 9 billion oscillations of a cesium atom. Sounds random, but it is. That number was picked to match the old astronomical second, which came from centuries of observations, which go back to Babylonian math, copied from Sumerian clay tablets, who said they got it from the Anunnaki. The most precise timekeeping in human history still uses a base unit that predates writing itself. Deep in the guts of the internet, servers keep themselves in sync. They use network time protocol, NTP if you want to sound technical. Every time your phone pings a server or you hit refresh on a page, they trade timestamps, counting seconds from January 1, 1970. Why that date? It's random, convenient, just a starting line. But the way the seconds themselves are counted, the way time slices up into neat little pieces, yeah, that's ancient. It's all rooted in the old, inherited system. The second, the 60, the circle. Every email, every click, every stream is stamped by math invented thousands of years ago. We're running the digital world on Bronze Age time. Maybe the real trick wasn't the Anunnaki making anyone believe they were gods. Maybe it was slipping their math into the bones of our world, so well that we all keep using it, not because we believe, but because it just works. You don't need faith for this. You just need clocks, compasses, calculations. As long as people count hours, measure distance, aim for true north, or plot a course by satellite, the old system keeps humming along in the background. Think about airports in the middle of the night. Most people are asleep, but controllers sit in towers, watching dots crawl across radar screens. Every plane's got a heading, 0 to 360 degrees, just like ancient Sumerian sailors charted the Gulf. These controllers aren't thinking about Mesopotamia. They're thinking about safe landings. But the math is the same and it works. It always has and it will as long as humans fly. That's the sneaky brilliance of Base 60. It doesn't care if you pay attention to it. It doesn't need rituals or worship. It just runs, quietly shaping how you slice up time and space. Your alarm rings at 6:30, straight out of the sexagesimal system. You check the weather 72 degrees, a number that divides nicely by 60. Your GPS spits out coordinates. You schedule a 90-minute call. You watch the sun set along an azimuth of 285 degrees. All day, every day, you're moving through a world mapped by a math you didn't invent. You probably don't believe in the Anunnaki. Maybe you think they're just a story, a metaphor, a myth, but belief is beside the point. You still follow their instructions. Why? Because they're useful. Because tossing them out would mean inventing everything from scratch. This old math is so deep in our world that questioning it almost feels like questioning gravity. The Sumerians got this. That's why they said the system came from beings greater than themselves. Why math was revelation, not invention, something sacred you don't mess with. They saw the elegance and knew it was bigger than them, maybe even bigger than humanity. Maybe it was divine, maybe from somewhere else, or maybe just the work of a civilization lost to time. Either way, the Sumerians saw themselves as receivers, not creators. And that's us too, just the latest in a long line. From Anunnaki to Sumerians to Babylonians, Greeks, Islamic scholars, European astronomers, to the engineers running today's world, the Base 60 system kept passing down. The symbols change. The gadgets change. But the core, 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle, never budges. The instructions stay. Maybe the Anunnaki foresaw this. Maybe they knew that bodies die, but math sticks around. Names fade, stories twist, but a good measurement system becomes invisible, woven into daily life. No need for monuments or temples. Just plant the knowledge where it's most useful and trust that people will keep it alive because they need it, not because they remember where it came from. Floods came, cities vanished, languages died, empires rose and fell. The math survived. Copied from tablet to tablet, whispered across generations, handed off from one civilization to the next. Until now, right here, right now, you measure your day in hours and minutes and seconds, trace your route in degrees and coordinates, following instructions left by people whose faces you'll never see, whose names you'll never know. All you have to do is glance at the clock. Storage rooms tucked away in museums from Berlin to London, Chicago to Philadelphia. Ancient clay tablets sit quietly in their carefully controlled boxes. No light, no moisture gets to them. Each one, covered in tight wedges pressed by a reed thousands of years ago, has survived everything: the collapse of empires, the fatting of languages, the long forgetting. The civilizations that made the clay are gone. The cuneiform script outlasted the words it once captured. But the numbers, still right there. Still readable, still doing their job. A multiplication table from Sumer works today just like it did in 2500 BCE. Those instructions don't go stale. Look closer and you'll spot a phrase that keeps coming up, scattered across different tablets, cities, and centuries. From distant days, according to the old writings, as it was established by the Anunnaki. The Sumerians didn't take credit for their own math. They called themselves students, scribes, caretakers of a knowledge that came from somewhere older, from beings who knew the universe better than humans ever could. Maybe they were onto something. Maybe Base 60 fits reality so well because whoever came up with it actually saw reality more clearly. Maybe the 360-degree circle isn't just a random choice. It could reflect some deep structure of space, some hidden geometry we use without understanding. Maybe splitting time into units of 60 lines up with rhythms built into our bodies, cycles we don't notice but still follow, ticking away in sync with sexagesimal divisions. Or, maybe the Anunnaki were just really sharp mathematicians, human or not, who realized 60 just works better for certain math. They had the foresight to make it the standard, figuring that if the system was useful enough, it would outlive them. And they were right. Nobody had to remember their names for the numbers to survive. Either way, here we are, 5,000 years on, living by their system. Your day runs on their clock. You use their coordinates to find your way. You measure angles the way they did. You've never questioned it. It's just how time and space are split up, how things have always been, how reality gets measured. The Anunnaki didn't leave rules carved in stone for priests to guard. No, they slipped their instructions into everyday life, measuring, calculating, keeping time. Do it long enough and it becomes habit. Habit turns into culture. Culture feels like nature. And once something feels natural, you don't even see it anymore. It rules your life without you noticing, shaping your world without saying a word. Maybe that's the real secret those tablets keep in the museum dark. The most powerful knowledge doesn't need you to believe in it. It just needs to be so useful you use it without thinking. The Anunnaki didn't care if you worshiped them. They just needed you to use their math. And you do, every single day. Every hour, every minute, every second. Morning comes, alarms go off, people get up to another day measured in this old time. The system keeps running. 5,000 years on, base 60 keeps structuring everything you do, invisible and unthanked, so natural it feels inevitable. But it is. It was designed that way, taught to the Sumerians, passed down to you. Winds sweep over the dust of Nippur, Eridu. The temples are gone. The Sumerian language is lost. The numbers remain. The math endures. And every time you check the time, you read a message from the Anunnaki, passed down through 200 generations, still accurate, still shaping your day. What if that was the whole point? Maybe the Anunnaki knew civilizations fall, but systems last. Maybe real immortality doesn't come from monuments or books, but from creating tools so essential that people will carry them forward forever. Not because they remember you, but because they need what you made. The instructions you use every day, the base 60 math behind your clock, your compass, your GPS, they're not just relics from some distant past. They're alive. They work right now as well as they ever did. The Anunnaki handed that down. And their gift, it keeps on doing its job. It keeps ticking, measuring, guiding us with a kind of quiet genius. So when you're lying in bed tonight, your mind's slowing down. Think about the numbers that shape your sleep. The hours until sunrise. The minutes left before your alarm goes off. Even the degree of warmth curling through your room. All of it measured in a system older than the oldest stories. These numbers were set up before pyramids, before empires, before anyone even tried to remember where we all began. We still use the Anunnaki's instructions. Not out of habit, not because we think they're holy, but because they work. 5,000 years, nobody's found a better way to slice up a circle or keep track of time. And maybe that's the real wonder here. Not that so-called gods once wandered the earth, but that they left us something that lasts. Something sturdier than legend, tougher than stone, mathematics. Memory fades. Math doesn't. It just waits, always ready for the next person who needs to measure, calculate, or find their way from earth to sky. The instructions are still here. The numbers don't disappear. And somewhere in the hush between seconds, in the space between degrees, the Anunnaki's legacy keeps going, unseen, unending, still teaching us how to count the moments.